Our lesson for today is one of the most useful and important technology in our society. It is the hydraulics. Hydraulics comes from the Greek words hydro means water and olix means pipes. It is an engineering discipline which applies the theoretical science of fluid mechanics in order to generate, control, and transmit power through the use of pressurized liquids. As such, hydraulics can refer as a branch of science as well as a type of mechanical system. Throughout history, people have always drifted towards water. We build cities and major waterways and use them as thoroughfares. We use running water to power wheels that help us repair food and fabric. Hydraulics, or the use of fluid power to run machinery, have been around for quite a while, for over 2,000 years. It is tough to say exactly who invented hydraulics or when hydraulics were invented. Hydraulic systems have been created from the work of great minds like Blaise Pascal, Joseph Bramah, Leonardo da Vinci, and Galileo Galilei. Hydraulics eventually found their place in the modern world with wide-reaching and powerful application. The jet of water sprayed by a Schultz water piston and the suction of a sink plunger are examples of basic hydraulics. Advanced hydraulics can be found in heavy earth moving equipment, cranes and lifting platforms, industrial machinery, and many vehicles. They are even hard at work in the human body. One example of a hydraulic system with which everyone is familiar is our circulatory system. Our hearts use hydraulics to pump our blood around our bodies and valves to govern the flow. Since hydraulics is concerned with fluid mechanics, the most obvious component of any hydraulic system is the fluid. In our example of the human circulatory system, the hydraulic fluid is our blood, and in industrial system, the hydraulic fluid would typically be a standard mineral oil, phosphate ester, water glycol, or skydrol, depending on the application. The other main components that make up a hydraulic system are often referred to as hydraulic power pack. It comprises of the following: a prime mover, the hydraulic pump, a reservoir of fluid, pipework and hoses, actuators, and valves. In combination, these form the basics of an hydraulic system. The sinusoidal node applies pressure to our body's hydraulic system. The sinusoidal node is our circulatory system prime mover. In an industrial hydraulic system, a prime mover would typically be an electric motor or diesel engine. It is what gets the hydraulic system started by powering the pump. In our heart, the left and right atria acts as our hydraulic pump. In industrial system, the hydraulic pump converts mechanical energy into hydraulic energy by moving or transmitting the hydraulic fluid. Types of hydraulic pumps in industrial use are gear, vane or piston pumps. It displays fluid volume against a resistant load or pressure. As this pressure is applied, the hydraulic fluid moves around the system. In our circulatory system, it is our veins and arteries that operates as hydraulic fluid lines, transporting the hydraulic fluid or blood around the system. While in industrial system, it is the hydraulic valves that are used to start, stop, and direct the flow of hydraulic fluid in the system. Hydraulic actuators comes at the end of the process where the hydraulic energy is converted back to mechanical energy. This can be done through using a hydraulic cylinder which converts hydraulic energy into linear motion and work, or a hydraulic motor which converts hydraulic energy into rotary motion and work. Another important element of an industrial hydraulic system is the reservoir. The reservoir holds a volume of hydraulic fluid. The reservoir plays several important roles. First, it allows any solid contaminants to settle at the bottom of it, ensuring the purity of the system and reducing contamination that could cause failure. It also transfers heat from the system, which might prematurely damage seals or components, and also serves to help air and moisture to be released from the fluid. Hydraulic principles. Particles in liquids are close together, meaning that liquids are virtually incompressible. When moving around, the particles collide with one another and the walls of the container in which the liquid is housed. Because of this property, a pressure applied to a liquid will spread to other points within the liquid. Most notably, the pressure is transmitted equally in all directions. Even if the pressure is applied on a liquid at a single point, it will spread evenly to other points in the liquid. Although we know that pressure and forces are spread through liquids with the pressure transmitted equally in all directions, it is important to understand that pressure and force are not quite the same thing. Pressure is directly proportional to force. However, pressure also takes into account the area over which the force is applied. Pressure is calculated using this equation. Pressure equals force divided by cross-sectional area, where P is pressure in pascals, F force in newtons, A cross-sectional area in meters squared. In this way, hydraulic systems enable smaller forces to be multiplied into bigger forces. This is what makes hydraulic system so useful. More topics about hydraulics will be discussed in our next video. Bye!